Welcome back to Reimagine 2020. I'm Yonah. Wait, before we begin, first the disclaimer: you're probably wondering why I'm dressed like this. This is our Halloween, our holiday themed conference. So this is a Israeli Jew's best attempt at dressing like Christmas. I don't know if I got it right or not, but I just saw like my face, like what I looked like on screen before I started. Like, wait, you're probably wondering what I'm dressed like. All right, now we can start. Here we go. Here we go. Welcome back to Reimagine 2020. I'm Yonah Hochhauser, and today I'm glad to be joined by Emin Gün Sirer, founder and CEO at Avalanche, and also professor of computer science at Cornell. Emin, thanks so much for joining us.
Thank you so much for having me, Yonah.
All right, well, it's great to have you. And for those viewers of ours who might not be familiar with who you want to give a little background, kind of, who you are and how you got into blockchain.
Sure. Very quickly, I got into blockchain way before it was a thing, way before the term was coined. In 2001, 2002, I started building a system called Karma. So that's 7 years or 6 or 7 years before Bitcoin. I was working on a cryptocurrency with proof of work minting in it. I believe it's the first cryptocurrency that minted coins via proof of work. So I was doing Satoshi-like things before Satoshi was around. Except, he came along 6 years later. He improved on a substantial portion of what I had worked on. You didn't know about my work. That's okay. All the academics know about my work. In any case, so, when Bitcoin started going big, I looked into that protocol. I found with Itai Eyal, the postdoc at Cornell that I worked with for this work, we found the biggest known flaw in Satoshi's consensus protocol, something called selfish mining, a scheme by which you can make more money than your fair share as a miner in Bitcoin. After that, I worked on the safety of coins at rest with things like covenants. I worked on a whole bunch of other things, like layer 2 protocols, on characterizing scalability, on characterizing decentralization. But most recently, the most exciting thing that I've been working on is for the last few years, I've been working on a new system called Avalanche. And at the core of Avalanche lies a new consensus protocol, the likes of which have never been experimented with before, that is far, far faster than everything else. And we just went mainnet with Avalanche about 2 months ago with a coin called Avax. I'm having a blast. And my goal now is to just work up the layers to show the world equivalent breakthroughs at every layer of the stack, both the consensus layer, the DApp layer, and the layers above. So it's been a fun ride for me.
Well, it's quite the resume you have there. And before we dive into what you're doing now and where you've gotten, let's talk about where you came from. You mentioned that you had, I believe it's called Karma. That was 2002. That was before even Satoshi, before Bitcoin. And you mentioned he made some improvements upon it. And I just want to ask, what were those improvements that made it so successful? What were the lessons that he learned that you would do differently if you could?
Oh, there are so many things I would do differently. The main thing I would do differently is I would time it better. So when I did Karma, it was 2002. And published in 2003, I think. And let's see. I don't know how many of your viewers remember those days, but I was a very young assistant professor. I had discovered this area. I thought, whoa, this is really cool. And I did Karma for keeping tabs on people in peer-to-peer file sharing systems. I don't know if you remember, but everybody used to want to download files. Nobody wanted to seed files. We call these people leechers. They were leeching off the network. You can never get people to contribute to the common good. It's a problem for politics. It's a problem.
Give them economic incentive. You got to give them an economic incentive.
Yeah. Then they work. Exactly. You got to give them something for the hard work they do. So I was like, why don't I invent some meaningless internet currency? And then, they have to pay for blocks using that currency, and they have to earn that currency by providing blocks. So that was the work that I did in Karma. My older mentors, older professors pulled me aside and said, look, this is cool. It's interesting. But, 9/11 just happened. Everybody's up in arms about terrorist financing. And here you are trying to build some kind of an economy. What the heck do you think you're doing? This will never get funding. This is a terrible idea for a young assistant professor. they were right.
Mm-hmm.
They really were right. It was a terrible time at the time for a young assistant professor. And so I kind of, cooled off of the area, and I went back in 2000, after Bitcoin came up. What would I do differently, and what did Satoshi do differently from me? So he has one big, brilliant technical breakthrough. In Karma, I was using what we call a classical consensus protocol. So you would have an account, I would have an account, and we would have these things called bank sets, a set of nodes that keep tabs of on that keep track of your account balance and my account balance. They're kind of
Mm-hmm.
like bank nodes, but they're peer nodes.
Mm-hmm.
So that's okay. And they communicate with each other using classical mechanisms, the kinds of things you might find in ETH2O, the kinds of protocols and communication you might find in EOS, and so on. So
Mm-hmm.
this was all like very old school stuff. What Satoshi did that was brilliant is he used the coin generation scheme based on proof of work. He coupled that with the consensus protocol. And suddenly he had a different approach to consensus altogether. And that's how he managed to build this thing that's super robust. Karma,
Mm-hmm.
if it had taken off, would not have been as robust. So,
Mm-hmm.
it would have been as robust as Ripple, Stellar, EOS, ETH2, which in my opinion are not very robust systems. So
Mm-hmm.
it would probably have been successful nevertheless. The other thing that he did really right, there are two other things he did right. He got the timing right. He came right after the 2008 crash. The economy had tanked. We did not, and to this day, I still do not trust the people behind the economy. We
Mm-hmm.
do not trust the financial system as a result. It
Mm-hmm.
crashes. It's just empirically obvious that every decade you get a crash. And so we're overdue for one, by the way. And then the other thing he did that I would do differently is he set his sights very high. So I was going for something modest, something achievable, something humble. And he was like, you know what? I'm here to undo the dollar. I am here to serve as an alternative to the USD. And that's a tall order. What are the chances of success with that? It's very tough. And
Mm-hmm.
I was a real more pragmatic guy. I've always been a more pragmatic person. And so, especially then, I was younger, and I was like, look, this is an achievable goal. I just want to use this thing for people who are trading files on the internet, essentially. So I would
Mm-hmm.
do that differently. Always set the goals very, very high, get the timing right, and and of course, he had that one technical breakthrough. Those kinds of technical breakthroughs do not happen all that often. So
Mm-hmm.
there are just so that the viewers know, there's a crap ton of people out there, like maybe 6,000 coins out there. There are probably hundreds of projects that claim new consensus protocol. There haven't been that many new consensus protocols. All of these are the same stuff dressed up. So in short, in the 45 years that distributed systems has been around, for the longest time, we had classical protocols. Then came Satoshi's protocol, what we call Nakamoto consensus. So that
Mm-hmm.
was the second big breakthrough in 45 years. And now we have the third big breakthrough with the Avalanche Consensus protocol.
Mm-hmm.
So there have only been three big ideas in this space.
Wow. And by the way, I'm starting to think that you are secretly Satoshi, who realized that after 6 years of listening to his college professors and mentors said, you know what, I'm going to put this out, but anonymously, and you timed it perfectly and you learned from your mistakes. But now you've done your third great achievement, which is this new consensus. Now, I thought that Avalanche launched with two consensus engines, Avalanche and Snowman. You want to explain a little bit about how Avalanche
Sure.
consensus works?
Sure. Yeah, I can a little bit. So do you want to talk? Do you want me to talk about how this protocol works?
Mm-hmm.
I can try to make it accessible. So there are really three approaches to consensus protocols. One of them is the classical approach, where essentially I want to pass a law. Okay, and there have to be some people who decide, and all of the classical protocols work by collecting signatures. It's kind of
Mm-hmm.
like running a parliament. We want to pass a
Mm-hmm.
law. Did a supermajority of our lawmakers decide that this is a good law? And if you get not enough, if you get like 51 signatures out of 100 senators, that's dangerous. One of your senators could be Byzantine. He could be a trickster. He says one thing one day, says the other thing the other day, then confuses the issue, and you can't tell. So you got to get a super majority of these guys. And collecting those signatures involves every senator, every node, talking to every other node. And that's why these things don't scale. So the best classical algorithm, the best classical protocol is one that was first authored by my student. I sent him off to the West Coast for a summer. He came back and said, this was kind of cool. It turns out Facebook is going to pick it up, and it's used for Libra. And the best protocol in that family is intended to be used by about 100 validators. So Mark Zuckerberg and 99 of his best friends. So these things don't scale. They're really they're fragile. They can break apart. And then comes Nakamoto. He comes with this mining idea. I'm not going to belabor that point. There are many explanations of how that works. It's an arms race. All these miners are trying to add blocks to a chain, and that's fine. So the way the Avalanche protocol works is substantially different. Let me try to give you an analogy. Suppose we want to achieve consensus. And we're not in a tiny little Senate with 100 people. We don't even know who's in the Senate. Okay, we're going to be, let's say we're in a stadium, a giant stadium like the one in Brazil, 100,000 people, Maracaibo Stadium. Okay, I know some people there. You know some people there. I see you with your hat in the crowd. That's cool. I'm like, hey, Yonah, how's it going? And there are 100,000 of us, but we don't know everybody precisely. We can't know everybody precisely. We don't want a protocol that requires us to know everybody precisely. Okay, and if we were using classical, I would have to ask everybody, and everybody would have to ask everybody. It's 100,000 squared. That's a really large number of messages for a decision. So we don't want to do that. So what I do is I do the same dumb thing repeatedly, and it's a very simple thing. And it turns out this achieves consensus. So here is let's actually set a scenario here. Suppose we're trying to decide if Alice paid, so there are two transactions. Alice has $1. She says, I'm hereby paying Bob, and I'm hereby paying Charlie. So she is doing something really, really questionable. She is doing a double spend. And we as a collective should say, Bob, you got paid. Charlie, you did not, or vice versa. We don't care how it turns out, right? But we got to pick one of these two. So this protocol works as follows. I pick 3 people in the audience in the giant stadium. I say, yo, Yonah and Jimbo and Jane, which one do you favor right now? Do you think Alice paid Bob, or do you think Alice paid Charlie? And they come back with responses. And let's just simplify it. Let's just say red and blue for the 2 transactions. They say red, red, blue. And I go, okay, looks to me like the crowd, based on my subsampled votes, the crowd is tending towards red right now. Now, I might be wrong. For all I know, it's a stadium full of blues, and I picked the 3 red people, Right. But this is what I sampled. So I flip my color to what I sampled. And you do the same thing while I do this. And it turns out, and this is the magic part, there's a very strong proof that says that in a very small number of rounds, if I repeat this process, we will all pick the same color. Now,
that's if everyone's asking 3 people. If enough people ask 3 random people in the crowd, that majority will eventually, with enough rounds, will get finality and consensus.
Exactly. And it's so bizarre. It's really bizarre. Why wouldn't it just be a mix of colors, right?
Right.
But if you think about it, what's the worst that can happen? The worst is it's a 50-50 mix of colors. And after 1 round of this, it's incredibly unlikely to be an exact 50-50 mix because of random variation. Some people will sample red, some people will sample blue. Overall, one color will have a slight majority. Then the next round, there will be more of it. Why? Because we started with more of that color. And then the next round around, it's going to be even more. And then suddenly, now imagine, for example, towards the very end, if there's only 1 red left, then the next round he'll turn blue for sure, because whoever he samples, he's going to get blues. Right. So you can see how this thing goes. Towards the end, it speeds up a lot, and then you suddenly find yourself having converged. And so this is a phenomenon known as metastability. We created a system that is unhappy when it's in an intermediate state, And when it's all one color, then it's super happy. It takes a lot of effort. In fact, it's impossible to get it. Once we've decided red, we are done. Like nothing can make me flip because all my friends are red. I keep asking them, they say red, I go back to red. So so that's the informal description. The math is quite hairy and complex, but
yeah, I'm sure you've done the mathematical equations, and it's probably way beyond me and way beyond this conversation. But at the end of the day, we started off this conversation with the truth. Economic incentive. Every system needs economic incentive. You said that the problem with government, no one wants to do good. No one wants to be a seeder. They want to be a leecher. And so in this scenario, where's the economic incentive? Do only the people who vote the correct color get the reward? Is that if I say red and really blue's the final color, I lose out? Where's the economic incentive to pick the right color?
The economic incentives come from your investment, your stake in the overall system. So to participate, what you need to do is you need to hold some AVAX tokens. So without that, then there are two problems. One is you don't have any skin in the game. And the other one is that you can pretend to be, a bazillion Yonahs. And, me and my friends will get dwarfed by the presence of all these guys in Santa hats. And every time we ask you, you can then steer us in any kind of a direction. So we need to make sure that you cannot overrepresent yourself. And the way we do that is by forcing you to acquire what we call a stake. And so those two things are at the root of security for any blockchain, but also for Avalanche, because Avalanche is a proof of stake system at the heart.
Yeah. So I don't get why is this system of the breaking it down into threes or whatever the subgroups may be, why is that better than a traditional proof of stake system where you're just people have the same economic incentive by picking validator?
Because if you were to try to use any other protocol other than Avalanche, it will be slower than Avalanche is. So, for example, Ethereum 2.0 is a classical protocol, and it's going to, if it works next year sometime, when it works, it's going to take 5 seconds to make a decision. And in every decision, there will be up to, at most, 250 nodes involved. And more than likely, it'll be fewer than that. So, so that's that. That's the best to come. It doesn't even
exist. It scales. What you're saying is that it gives you the same security as all these proven other consensus models with the scalability. I saw, I don't remember offhand, you probably do, but I remember seeing is really high transactions per second and really quick transactional finality times.
Right, exactly right. So transactions per second in Avalanche are, so we've gotten in the lab numbers as high as 19,000 TPS.
Wow.
But right now, our system, even as it is right now, and in the wild, it's 3 times faster than Visa. I never thought I'd be able to say that. Nobody else can say this.
Yeah.
And finality is less than a second. It's about 300 milliseconds, which is a slow eye blink. So in the time I do this, the whole system globally across the world, involving nodes in Australia, Russia, China, Europe, etc., makes a decision. It's pretty insane how fast it is. And you can't get these speeds out of any other protocol. And the other thing to note, of course, is it's open. Any number of people can participate. So that puts it in a different class. So I can have millions of participants in the Avalanche protocol, and nobody else can get anywhere close.
And if we're having an honest conversation, we can't only focus on the incredible pros, because there's no downside here. So what are the possible risks or potential downsides? Because it seems like this should beat out every blockchain at all use cases.
It should, objectively speaking, on technical grounds. Let me talk to you about the potential downside. So I get this question a lot. They're like, well, it seems like this is just better in every way. Shouldn't there be some trade-off, right? And that's the thing they say. And because people have been, this is very, I don't know what, people have been taught that you can't get something for nothing, right? That every new thing must have a downside. And that's generally not true, right? Like a bulldozer is much better than a shovel. It's on every earth moving metric. It's better. It has the downside that it needs gas. So let me give you the downside for Avalanche. It's a new protocol. It's the implementation is from scratch, and so it's brand new, and we will need to shake out a lot of the corner cases, a lot of the unknowns of this new way of approaching consensus. So if one were to use Nakamoto consensus, different deal, right? Very well understood protocol. And if one were to do what ETH2 is trying to do, okay, ETH2 is trying to do sharding, which is also not well understood. But if you were to try to do what EOS is doing, that is incredibly well understood. No risks there. And we're not doing that. We're doing something riskier. So there are technological risks here. There is also the risk that the proofs are flawed, that we think this thing is going to converge, but it won't because of a mistake in the proof. I think this is highly unlikely, but it is a possibility. So there are a lot of unknowns that come with having built a big different rocket. And it is far faster, better than all the other rockets that came before it. So that's cool. It works right now. It's been out 2 months. So so that's kind of neat. But I do expect to see corner cases and issues come up in the future.
And what people don't realize, and this is something that often comes up in my conversations, listen, like you mentioned, this is a new protocol and you're still working on the kinks. So like I've always said that ETH was a first mover for smart contract enabled a blockchain. And they've been so successful. There's all this DeFi, all this value is built upon it, but it's exactly all that value that is hindering them and hamstringing them from innovating because they're scared. They're scared to launch ETH 2.0. They're scared to move all these assets onto the ETH 2.0 because it's so valuable. They don't, if there's a bug, if there's an issue, they don't want to lose all that value. So it's actually opened up a huge opportunity for new protocols such as your own that aren't burdened by, oh shit, if I fuck up this one letter here, it's gonna, there goes $500 billion. You actually have the ability and the freedom to innovate here. So I do think you have a wonderful opportunity. And I would say that you truly are competing against ETH 2.0, not really ETH 1.0.
No, that's exactly right. I love ETH 1.0. I absolutely love it. I consider myself an essential part of the Ethereum community. I was the number 5 most influential person in Ethereum for a long time, blah, blah, blah. Like there are a whole bunch of metrics. I love Ethereum 1. I think Ethereum 2 has flaws. I've told Vitalik this multiple times over the years. And so I think what we're doing is a way to hedge. We want to make sure that DeFi is here to stay. We want to make sure that DeFi grows and supplants Wall Street with better technology. So yeah, and we have an opportunity. We have a window open in front of us.
And it seems like right now the name of the game is composability. Is this idea of building financial building blocks and cross-chain interoperability? How will Avalanche play nice with other blockchains? Will there be able to be cross chains and things of that nature?
Absolutely, absolutely. We just announced maybe 2 days ago our first cross chain bridge. So it's quite easy to move assets from other chains to us and vice versa. I am looking forward to wrapped AVAX on other chains to be used as collateral. What else are we doing? We're doing so many things, Yonah. I can't even keep tabs on what we have announced and what's still in the works. But we are here to play nicely. I think one of the main things that I have is a commitment to science. And we're not maximalists. We don't think there's going to be a single winner who takes all. It's going to be a fun area. Ethereum is doing really well, which I'm very happy to see. DeFi projects need scale, which I'm happy to provide. They need low fees, which we're very happy to provide. And we are here to make sure that the space succeeds overall.
And I want to pick your brain because you actually wear 2 hats. You're not just starting this incredible protocol, but you're also a computer science professor at Cornell. And so as an educator yourself, I wonder, how does one educate on a topic that innovates so fast? How do you make a curriculum when by the time when you wrote it down in your office to by the time you get to the classroom to teach it and put it on the board, it's already outdated. It's already, gone. So how does one teach how does one teach blockchain when it innovates so quickly?
Exactly. So such a good question, and nobody really, I didn't think anybody really understood my pain, right? So
I got you, my man. I got you.
yeah, I know. There are really two big problems. One of them is what you said. It changes so quickly, and I find myself teaching out of white papers, out of blog posts that are just rolling off the shelves, and the state of practice is so far ahead of the cutting edge of research that people
Mm-hmm.
are deploying these contracts that are poorly understood, and other
Mm-hmm.
people are pouring in billions into those contracts. So it's pretty risky, pretty crazy. So that's one issue. But it also has its upside. It's so easy to motivate the students. You just say, look, here is some code. Oh, do you see this little problem? It looks correct, right? But because of, because they forgot to swap these two lines, they lost, a third of the money that they collected. $53 million were stolen because by one person out of their house, right? Because of the DAO hack. And it's both a motivator and a source of excitement for young students, and also a challenge for the educators. But that's good to have. The educators should be challenged, not the students. Students should be motivated. The second problem, which is even bigger, and this is actually a real problem, is the space is so broad and interdisciplinary. So to really excel at it, one has to have mastered computer science, economics, game theory, mechanism design, and must have a very good understanding of social processes as well. So this is really hard to find, and they have to understand business workflows. It's just so hard to find. I try to compensate for my own shortcomings by inviting people to come and lecture. Um, and so we've had, I think Cornell is consistently the school with the most number of courses. And and so that's been fun. But keeping abreast of all the changes and excitement has not been easy.
Well, and that just naturally leads me into my next question, because that is such an important point here, where the unique thing about this blockchain space and how it's evolved, it really it requires a broad knowledge base. You need to be that cutting edge of computer science, but also cutting edge of financial products and also game theory, and there's so much going on there. So my question to you is actually twofold, and I guess I'll break it. I'll break them up. I'll ask you the first question first. Um, which part of that do you think is holding back the others? As in, is the computer science not there yet, or has no one thought of the proper financial tool to innovate yet, or is it no one has gotten the game theory there yet? What is that one aspect in this whole very broad knowledge base that's holding back the others?
So until recently, it was the computer science. The consensus protocols we were using were just too slow. The architectures that people were using for their chains were all copies of Nakamoto's original work. So one coin, one system, one virtual machine. And I think we've broken through both of those barriers with Avalanche. And we didn't know governance. We didn't understand governance. And so Avalanche has fixed, I think, these three issues. So Avalanche is fast and scales. It is flexible. It supports more than one virtual machine, and it's an enabler for other people to issue their coins on it. So you can use the underlying, this hard work that we did, putting together a consensus engine. You can just use it and build your own systems on top. And it has governance built into it. So your systems aren't stuck with some parameters on the day of their creation. So that was then. That was about 2 months ago. So talk about a fast-moving field. So now I think we have the technological foundations moved up. I never thought we would be faster while being decentralized than Visa. We have that solved. The next problem is that we are inwards oriented. DeFi is an inwards oriented game. To really excel at DeFi, you have to have mastered Ethereum's internals, and you have to know how to take your money and send it through the 37 different steps to get the yield that you want with a flash loan in the middle and whatnot. So that's fine for us, but it's just not going to take off mainstream like that. So the next level, I think, is going to have to be projects that are outwards oriented. And from like since day one, we've always been outwards. I've always been outwards oriented. The reason why I'm not a maximalist is because the value trapped in crypto right now is tiny. It's less than $1 trillion. So it's
Mhm.
like it's not that much money at the end of the day. The amount
Mhm.
of assets that could be traded on a blockchain is in the many digits of trillions. And
Mhm.
instead, we're now fighting. I mean, there are all these maxis fighting over like table scraps, essentially. Let them
Mhm.
do it. That's fine. It keeps them occupied, gives them something to do, maybe. But my eyes are set on getting into crypto. All of these assets that mainstream is currently using really retrograde systems to trade, and that's going to change the world.
Mhm.
These new assets should be easy to use. That's going to also change the world. If you copy Nakamoto, like Ethereum has done and everybody else has done, then what you'll end up with is a system that's really hard to deal with for normal people. And
Mhm.
that's one of the things that we're going to be changing with our next upgrade in Avalanche coming up in a few weeks.
Mhm. Now, first off, I personally don't get out of bed for less than $1 trillion. I mean, what is less than $1 trillion?
It's
Um,
nothing.
yeah,
You
but
almost
two,
kind of things.
yeah, right. But I think you brought up a really good point there. This idea of inward facing and outward facing, and I think that you have a really good mindset because, like you mentioned, a lot of people are just copying and iterating upon what Satoshi did, which is great and works and is effective. But it's also led us to this point where it's like in at least in my mind, as a blockchain user, as a crypto holder, it's like blockchain's great, has all these benefits, it's decentralized and it's low transaction fees and yada yada yada. But in my mind, also comes with that is just, it's harder to use because blockchain.
Yeah.
It's more confusing because blockchain. But it's nice to think that we can actually break out of that mold, and if we do things slightly differently, think and really put in the work and build new consensus models that might not require that. So you're saying with Avalanche, will we get to that point? Because I think for the mainstream adoption really to happen, they can't know that it's a blockchain, or it doesn't have to matter that it's a blockchain. The mainstream does not care what technology is behind the scenes. They don't care about the ideological reasons behind it. They just want a system that's quicker, faster, easier, better. And so, are you going to be able to do that with Avalanche? Is it being built in a way that you don't need to have crypto knowledge? You don't need to jump through hoops and loops and wallets.
Exactly. So Arthur C. Clarke has this quote, as many people know, that any sufficiently advanced technology is indistinguishable from magic. And like you said, we will have succeeded when people are using these systems based on blockchains without realizing that they're using a system based on a blockchain. So if you have to install MetaMask, if you have to worry about fees, if you have to worry about a fee that's too low, and so on, then we've already lost the game. And Avalanche, when we came out 2 months ago, we came out with essentially a solid foundation, is what I think we came out with, that inherited quite a bit also from the Bitcoin model. And but what we're going to do in the next few weeks is a new upgrade that's going to fundamentally change a few things. It will be possible to bring up a node and connect to the latest state of the blockchain in a jiffy. So you come
Wow.
up, and it's not like multiple days of syncing up to the blockchain. It just happens like this, and you're caught up, where you will not have to worry about fees. The fees are just going to be predictable, and they should be low for a long time to come because of the high speed of the system.
Mhm.
So these two factors put us in a very interesting territory, I think, because suddenly you can use these things and interact with them without having to worry about attaching a fee, without what the fee level ought to be, how long it takes to connect to the system, and so forth.
Mhm.
So yeah, we're making a lot of progress on those fronts. I also
Mhm.
was the one who added to blockchains the ability to withdraw funds after a theft.
Mm.
So if you come and take my funds, I can recall them from you. But if I do make a payment to somebody, then I cannot take back my payment. So this is something called covenants. Again, work with Itai Eyal, who
Mhm.
is now a professor at the Technion, and so these are the kinds of things that are necessary for general adoption. People want to be able to
Mhm.
say, "Hey, look, I pressed the wrong button" or whatever. But
Yeah.
they want to be able to not impact finality, but also be able to compensate for mistakes. So there are a lot of usability improvements that we can do.
And that idea of being able to get back the thefts, but not the purchases, is that the one that's built upon that someone has to input a code within a certain time frame or the transaction reverts? Is that how it works?
Exactly. That's exactly right. It's called covenants. Yeah. Exactly.
Very smart solution. And when I first read that, I first saw the headline. Oh, you can revert. I think now you allow ETH transactions to revert. It was also Bitcoin transactions as well. Bitcoin. And I was like, all right, I'll click on this. And then that's a really, really smart solution. So I tip my hat to you. That's really, really clever. And I hope that it gets more adoption and that kind of becomes a standard, because that does provide a great fix, an easy fix for this. But at this point, does that have to be manually inputted, the password for each transaction?
No, so there are multiple implementations of this. So we use these covenants to build vaults, and there are multiple vault implementations. The typical ones are like when you put your coins into storage, you vault them. And when you take them out, then you take them out and everything is good. If somebody steals the coins in your vault, that's the only time you do something special. You go in and say, hey, that guy, I know something he doesn't. I'll take the coins back from him. He just stole them from me.
Okay, very cool. So yeah, I do love that, and I appreciate you constantly innovating. I just talk about blockchain, but you're actually building upon it and creating and improving it. So I appreciate it. You give me what to talk about. Now, you did mention that you're also improving on Avalanche. You have the first major update coming, Apricot. I believe it's due out next month. Yeah. What should users expect from that upgrade?
So it's going to be mostly transparent. So they will not notice a thing if all goes well, and I hope all will go well. Following Apricot, they should see incredibly improved sync times. So nodes should just come up and immediately sync up. Following Apricot, they should also notice that fees are dynamic and change based on usage of the blockchain, and that the fees are predictable for long periods of time. So that's going to be a very different. And also, there are some other surprises in there as well that I don't want to reveal just yet. But related to ease of use of the chain, they should be able to interact with the chain without realizing that they're interacting with the chain. So cool stuff is coming.
That fees idea is really great. I mean, as the price of Bitcoin explodes, and then more just regular people and newbies FOMO in. Just my brother the other day, he bought some crypto for the first time, and he was trying to buy on using Uniswap or Ethereum. And he set the transaction, and he said, it never went through, or it went through hours later. And I said, well, how much transaction fee do you put? He's like, well, what do you mean? And it's just this idea of like, there's just too much. It's great for a power user. I do like the idea that there is the option for us power users and adopters to be able to put in our fees they want and really have this power. But if we want to go mainstream, if you want just regular people to use it, you cannot overwhelm them with options and overwhelm them with settings and fees. And so that is a great idea as well. One last question, because I do think that you're uniquely able to answer this. We spoke a little bit about the idea of blockchain education. And that's really what this conference is about, and the Blockchain Education Alliance is about. And we think it's really important to, the more we educate the public about this, the less we have to dumb down the product, but also it's good and it helps them use it as well, and it helps adoption. So when we're talking, in today's world, whether you're pro or against it, the main source of education as it stands traditionally has been formal education, and the higher education has been universities. And so right now, if you're trying to educate the masses, but let's say we're trying to educate the youth about blockchain technology. Do you think that it's best taught and educated in a formal setting versus a non-formal setting? And then on top of that, if it is a formal setting, because it's so broad, because we mentioned all the different aspects and disciplines that are required, do you think that it should be its own degree, or should it be a class on offer for, hey, I'm a computer science student and I want to take an elective, so I'll just take a blockchain class?
Yeah, good questions. So I generally think that formal settings provide the best infrastructure for efficient learning. I
Mhm,
know that it's not because of the education, educators, whatever, what the educators do. It's because you have a support infrastructure and you have a set of colleagues that are at the same level as you are, that are going through the same process with you, to whom you can be like, hey, yo, I'm stuck here, how do you do this, what does
mhm,
this mean, etc. So that experience is invaluable. Every time I learn something, I know how hard I worked to learn things on my own versus how hard, how much less I had to work when I had people learning the same material with me. So
mhm,
I'm always in favor of structured settings. And it's because of this peer group and peer support network that forms. And as for degrees, I don't think, yeah, I do believe that, of course, as I said, blockchains are super interdisciplinary, but I'm not a big fan of any field branching out on its own
mhm,
unless it's really really big. So I don't believe in a blockchain degree. I think one should get a computer science degree or an economics degree or a math degree, whatever the case might be. But a blockchain degree sounds too specific.
mhm,
Most people end up not working in the field that they thought they would when they were 18 years old, right? You start out at 18. I don't. I thought I was going to work in computer science, which I do now. I thought I was
mhm,
going to work in operating systems. I'm now off in cryptocurrencies. Everybody else I know has done career changes. What you want to be in command of is a large area and a big spectrum of tools that you can
mhm,
bring to any problem. So learning about blockchains is fantastic. You'll end up learning about mechanism design, about econ, about math, about distributed systems. These are just widely very useful going forward. But specializing in this to the exclusion of other material, I think is a bad idea. So
mhm.
it's like designing a balanced meal, right? So do we love our crazy paleo diet right now? Maybe, but these things change. So you should have a
Mhm.
more balanced diet when you're in school. So you've sampled every food, and then later on you can specialize if you like.
Well, I mean, I really appreciate you taking the time. I could tell that you're both a skilled educator as well as very knowledgeable in the field. Potentially, Satoshi, I don't know. I'll let your viewers decide that. But I mean, I really appreciate you taking the time, helping, kind of explain kind of both the background and the basis for what makes a distributed system work, as well as your unique solution, Avalanche. I'm very excited to see what comes from it. Apparently there's no downside, so I'm excited to hop on board. I'm going to get in early. I'm getting in early. People talk about they got a Bitcoin at $1. I'm getting an Avalanche. I'm getting in early, baby, before anyone
Sounds good.
is really on board. So
Come check out our community, Yonah. You'll love it. It's a very good
uh,
crowd.
and where could people, if they're interested in Avalanche, where could they come check it out?
They can just go to avalabs.org and
Mhm,
or avox.network. Those are good starting places.
mhm,
Avalabs.org is a very good one with the documentation to everything about the system.
mhm. Well, I mean, I really appreciate you taking the time, and I'm sure our viewers do too. And for all our viewers here at Reimagine 2020, I'm Yonah Hochhauser. Happy holidays.